applied Erashi because of the need for new screwdriving solutions with cobots. We are a Danish company called Spin Robotics, doing screwdriving tools for collaborative robots that enables factory workers to automate assembly tasks in general. Before the project, we had issues on achieving the torque accuracy on the screwdriving tools, so we applied an Erashi application experiment to explore how we could use AI for determine accurately torque during tightening operations in the industry. On top of the AI part that we have developed in Erashi, we have also created a mobile assembly station that makes it very easy for factory workers to move this screwdriving robot around the production. So I will say we can really recommend the Erashi project as a good opportunity for startup and scale-ups in Europe to develop new AI and human-centered technology. So we think it's really a success story. We achieved our goals and have now AI enabled our end-of-arm tools for cobot. So before the project, we had issues in determine accurately torque in our screwdriving tools for collaborative robots. Normal today, people are using, or company are using highly expensive sensor technologies for screwdriving tools in general. But we wanted to make a cost-efficient solution, so we can, so small and medium-sized enterprises actually can automate screwdriving operations. So we really struggled in finding a cheap way of getting high accurate torque measurements in our tool. So we saw the Erashi projects and the focus on the embedded AI and AI on the edge. So we applied and got to some very nice results by applying AI directly in our firmware. In the Erashi application experiment, we had one of the consortium partners, STM Microelectronics, to help us. They built a complete tool chain for optimizing AI and deep learning algorithms and put them on the edge directly on the microcontroller. So it has been very great to have them on board and get their help and assistance in applying these optimization tools, so we actually can take large deep learning networks and optimize them so they can be running on an STM32 MCU. So one of the results of the Erashi project is that we have achieved a very high accurate torque estimation. Actually, our precision recall in these models is up to 95%, and with an inference time in less than 10 milliseconds, because it's running directly in the firmware and in our electronics in our tool. So this optimization phase that we have worked on together with one of the consortium partners in Erashi, STM, have done that we actually can achieve this. So we're very happy about this. One of the things that we have achieved in Erashi that we didn't expect was the focus on eco-design and how we can make sustainable products. Before we started the project, we had not looked into how to design and produce our tools and our systems CO2 friendly, and we actually thought that the major impacts on the CO2 and on our products will be on the manufacturing side. But with the help of the Erashi consortium, we actually figured out that our CO2 impact is more on the power consumption at our customers. So that have made us focus on how can we get lower power consumptions during operation at the factory floor, because that's actually where we see the CO2 impact on our products. So that was one of the concrete benefits that we actually got from being partner in Erashi that we hadn't expected. So we're very glad of that. On the other hand, we also have got help on pitch decks and go-to-market strategies that have been very, very nice as well. And of course, the technical development with the help from STM Microelectronics has also been very, very good.